Hello friends, in this session we are going to see one of the topic again they asked in the UPSC exams, that is remainder theorem. Also this topic is very important if you are targeting SSC CGL kind of exam. But as far as banking exams are concerned, there will never be the questions on the remainder theorem. But it is easy topic. Once you understand the basic concept, you can solve any type of questions that they ask. So let us start directly. But before we start, of course, there is one or two things we need to discuss here. Let us start with a puzzle which will be related to this topic. Let's read this. One night, six pirates stole n number of gold coins. They decided to divide among them in morning, and they slept. Two pirates woke up and decided to divide all the coins among themselves equally and lived. But when they tried so, one coin was left. So they woke up one more pirate and they decided to divide all the coins among themselves equally and live. But again, one coin was left. So they woke up one more and same thing happened again and again. Finally, all six decided to divide all the coins among themselves equally. But again, one coin was left. What was the number of coin? Provided the number of coin was less than 100. So if you see this as a puzzle, if you go hit and trial, it's fine. But we are now mathematics students. So we should be taking puzzles as a mathematical equations and questions. And then we can solve it with a mathematics way. So what we are looking here is, we are looking for a number n, for a number of coins, which if two people try to divide among themselves equally. So that means if n is divided by 2, one coin was left means what? Whatever the quotient is, the remainder is going to be 1. Again, n is the number when we divide by 3. Again, the remainder is going to be 1 because one coin was left. That means n did not get divided by 3 completely. One coin left means there is one remainder in that division. Again, n is a number which when divided by 4, we are going to get the remainder as 1. Again, n is a number which when divided by 5, the remainder is 1. And n is again a number which when divided by 6, the remainder is 1. So what is that n that we are looking here for? Now consider, whatever that number of coin is, there is always one coin extra when you divide it by 2, 3, 4, 5 or 6. So if you remove that coin upfront, the number of coins now will be n minus 1. Now n minus 1 will be the number which will be divided by 2 as well, 3 as well, 4 as well, 5 as well, 6 as well. Because we removed that coin that was left out every time. So the one coin, if we remove, with the number of coins now, n minus 1 should be divisible by 2, 3, 4, 5, and 6. So what is the number that is divisible by 2, 3, 4, 5, and 6? That means what is the common multiple of 2, 3, 4, 5, or 6? Or because we have learned the topic HCF LCM, what is the least common multiple of 2, 3, 4, 5, 6? Now, if you see, that is going to be 6 into 5, 30. But 4, it does not divide 30. So we'll have to multiply again it with 2. So 30 into 2, 60. So 60, if the number of n minus 1 coins, that means it will be divided by 2, 3, 4, 5, 6. That means 60 should be equal to n minus 1. So that makes n is equal to 60 plus 1, that is 61. Because 60 coins if were there, that could be divided by 2 also, 3 also, 4 also, 5 also, 6 also. But because one coin is being left all the time, that means there is one more than 60. That is 61 number of coins. Okay, so this is again one of the very, very typical type of the questions. They just don't ask in form of pirates, but they ask in terms of a normal question. That what is the number n which is divided by 2, 3, 4, 5, 6? The common remainder is 1. So for all such questions, the general answer we can write is n is going to be the number which is going to be the common multiple in range. Common multiple in range means, as I gave here, the number should be less than 100. But if the number of coins said 100 to 200, so we don't have to find the LCM, then we have to find the common multiple in that range. So their least common multiple is 60. But the next common multiple is going to be 60's multiple, that is 60 into 2, 120. So 120 also will be the multiple of 2, 3, 4, 5, and 6. 60 into 3 is 60 into 4. So once you can find the least common multiple, then we have to find the common multiple in range. For range, it could be 100 to 200 as well. So if that was the range, then you know in that range, 120 will be the common multiple of these all. And then 120 plus 1. That means common multiple in range plus common remainder. Every time here, the remainder being 1, we call that as a common remainder. Common remainder is going to be 1. So common remainder is 1, and common multiple in this range now is 60. 60 plus 1. 61 is the answer in this case. So your answer keep getting changed if the range is changed. Okay. Okay, let's start now. The remainder theorem. Now, the remainder theorem obviously starts with the important concept, that is division rule. One must know what division equation is. In school days also we used to learn this. For example, if I want to divide 36 by 5, I write 5 7s are 35, and then we subtract 35 from this 36. The remainder is 1. If this is the division, this is called as the dividend, the capital D. This is called as the divisor, the small d. This 7 is called as the quotient, and the 1 here is called as the remainder. So the equation we can form here is this 36 is 5 into 7, 35 plus 1, that is remainder. That means dividend is equal to divisor into quotient plus remainder. Divisor into quotient plus remainder is the dividend. So this is the equation, because direct questions sometimes can be asked. They can directly say a number when divided by 8, the quotient was 7 and the remainder was 5. So what was that number? So rather than going for anything else, you should know that if you are dividing it by 8, that means 8 is the divisor, 7 is the quotient, and 5 is the remainder. So directly put everything in the value. So 8, 7, 56 plus 5, 61 will be that number. And such a way you can solve this. Easy? Let's see next part. Now we'll say what is remainder. What is remainder that we already seen in terms of equation, but practical approach. What is remainder practical? When we divided 36 by 5, what we actually did was, we if there are 36 ticks, 36 articles kept, and we want to make a group of 5, 5 each. So if you want to make a group of 5, 5 each, you divide 36 by 5 and the quotient comes 7. That means 7 proper groups can be formed. Out of 35 sticks, 7 proper groups will be formed. But the remainder will be 1, means 1 stick will be left out. Right? So this is the practical approach of remainder. So if you understand this part, that is going to be helpful very, very much. Let's see next part. Divisibility and remainders. We have seen the divisibility rules as a topic that was very important in other parts as well, but remainders also has its own application of divisibility rules. For example, the divisibility rule of 2 is we check the last digit. So if I ask you what is the remainder when 2, 3, 5, 8, 9 is divided by 2, what is remainder? So you don't have to check now the entire number divided by 2, what is remainder. You can just go to last digit because 2's test is last digit. So you can just check when 9 is divided by 2, what is the remainder? Remainder being 1. Here, the remainder is going to be 1. If I say 8, 9, 3, 6, 5 is the number when divided by 9, what is the remainder? So again, you don't have to manually just divide it by 9 and check the remainder. You can just go to the divisibility rule of 9, which being sum of digits. So you can just do sum of digits here. 9 is already gone because 9 is divisible by 9. 3 plus 6, 9 is again gone. 8 plus 5, 13. Right now, the sum of digit is 13. So 13 when you divide by 9, the remainder being 4. That means for this entire division also, the remainder is going to be 4. Because had the sum been lesser by 4, had this 5 been 1, so 8 plus 1, this number could be totally divisible by 9. But because instead of 1, it is 5, that means 4 extra. That's why the remainder is coming out to be 4. So that is what we have to look for, the divisibility rules. So divisibility rules also are going to help you to find the remainders. Let's see next part of it. Cancellation. Now, this is again an important rule. If I say what is the quotient if you divide 36 by 24. So you say 36 by 24, the quotient might be anything, but remainder is going to be 36 by 24. The remainder is going to be 12. 24 ones are 24, the extra is 12. But now if you see as a fraction, I can cancel out, say 2 from it. So if I cancel out 2 from both sides, this 36 becomes 18 and the 24 becomes 12. The quotient will be same. Whatever the quotient here was. Quotient was 1 here also. Complete quotient we're talking, not the decimal quotient. Complete quotient is 1. Complete quotient 1 here as well. Complete quotient is not going to change, but the remainder 18 by 12, the remainder is going to be 6. So it is the same fraction. This fraction and this fraction does not have a difference between values, but the remainder is changed. So if you have to go from this remainder to actual, because if I ask you this, you can't just short it down and tell me this answer. Answers are different. So if you have to go to the actual answer, you have to multiply the remainder with the 2 that you cancelled out. This is called as the cancellation rule. Usually, whatever we cancel from numerator and denominator, you forget it. You don't actually collect it. But here, you have to remember it. You have to write it down. And you have to know what we cancel out both with so that you can get back your original. So if I again see that both can be cut down now by 6. So 6 or even 12. Entirely 12. So if I cancel out 12 from both sides, 12 3s are 36, 12 2s are 24. And now I see the remainder is going to be 1. 3 by 2's remainder is going to be 1. So to get back to the actual remainder, I'll have to multiply this 1 with 12 because I cancelled out 12 from both the sides, right? So 1 into 12, the actual remainder is going to be 12. This is called the cancellation rule. I hope everybody got this. So there are different methods like cancellation rule, divisibility rules, and one more importantly that we call as the remainder theorem. What exactly remainder theorem? We'll see that later. But let me tell you one more thing about remainder theorem. There are different techniques to find the remainder. There are like 6 to 7 more than that techniques. There is Chinese remainder theorem. There is Fermat's theorem. There is Wilson's theorem. But we are not going to use much of the theorem because they are rarely will be used. Most of the time, of course, the logic-based rules or logic-based ways to solve the questions are helpful. So if you are a student who don't know anything about this, you are seeing this question for the first time. So what your approach should be is to form the pattern. So pattern making is again one of the very, very important technique to solve the remainder-based question. What do you mean by pattern? I have to see what is the remainder when 7 raised to power 777 is divided by 20. So if of course it's a huge number, so I can't go for directly that number. I'll say 7 raised to power 1 by 20. What is the remainder? Naturally, if the quotient, if the numerator is already lesser than denominator or divisor, so that means the remainder is going to be 7 itself. The dividend itself is going to be the remainder. Again, as we saw in the case of sticks, if there are only 7 sticks and if I say make the group of 28 sticks each, so you will say not possible, not even one group will be formed. So quotient will be 0 and all the sticks, all the 7 sticks will be considered as the remainders. If I say 7 raised to power 2 upon 20, what is the remainder? 7 raised to power 2 is 49. 49 upon 28, the remainder is going to be 21. 7 raised to power 3 upon 28. Now 7 raised to power 3 is 343. 343 if you divide by 28. 28 ones are 28. 663 means 28 twos are 56. So remainder is going to be 7. If you want, you can move further and see the pattern here. Whenever the power is odd number, the remainder is 7. Whenever the power is even number, remainder is 21. Whenever the power is odd number, the remainder is 7. Whenever the power is even number, again the remainder is going to be in this division, the remainder is going to be 21 and so on. So this is the pattern. If you observe, you know this power is going to be an odd number. So answer is going to be 7. So this is one of the way to solve this. Of course, we can now confirm it by another method as well. We just saw the cancellation rule. So I can just say 7 raised to power 777 means 7 raised to power 776 into 1 7 separately and divided by 28. And if I cancel out now, 7 here by 4. If I check what is the remainder here. Now the remainder here is going to be 1 because this remainder, individual remainder is -1 and -1 power even number is 1. We'll see this again in some time as a remainder theorem. But this remainder is 1 and because we cancel out 7, we'll have to multiply this 1 with 7 and the remainder is going to be 7. So yes, this is the correct answer. It means pattern also work. So pattern is one of the way. Divisibility rules sometimes you might find helpful. Then we saw another method that is called the cancellation rule. That is also important. But the most important of all, or the questions dependent on will be the remainder theorem. What do you mean by remainder theorem actually is? Remainder theorem means if I divide 20 by 7, the remainder here I know is going to be 6. That means if I have 20 sticks, I want to make group of 7, 7. I can make 2 proper groups of 14 sticks and remaining will be 6. If I say 20 plus 22 divided by 7, what is the remainder? Now I know from this individual, I had 6 as the remainder. That means 6 sticks were remaining. And here, 22 means 1 sticks will be remaining if I see individual remainder. So 6 sticks from here and 1 sticks from here can be grouped as 7 sticks total. And if I say now that 7 sticks will also form one of the group, so that is remainder is 7 or 0. 7 can't be remainder because we are making groups of 7. So 6 plus 1 being 7. 7 is also divisible by 7. Hence, there will be 0 sticks left or 0 will be the remainder. So that means you don't have to do 20 plus 22 is equal to 42 and 42 by 7, the remainder is 0. You can individually also say, check what is the remainder. If the remainder, individual remainder here is 6, individual remainder here is 1, and the sign between is plus. So you can just add these two and form your final remainder. Say 21 plus 22, 23 upon 10. What is the remainder? So you know the remainder here is going to be 1 and remainder here is going to be 3. And the sign between is plus, so 1 plus 3 is 4. And as you can see, this remainder is going to be 4. 44 by 10, the remainder is going to be 4. What about the product? If I say 21 into 23 upon 10, what is the remainder? 21 into 23 naturally is going to end with the number 3. And whatever the inferent number is, if we divide it by 10, the remainder is going to be 3 because 10's divisibility rule says last digit. So last digit here being 3, the answer is going to be 3. But if you apply remainder theorem now, this remainder is 1, this individual remainder is 1, this individual remainder is 3, and the sign between is into. So 1 into 3, the remainder is going to be 3. That means be it multiplication, be it product, be it subtraction, the remainder theorem will be work. For division, it won't work because division itself means whatever we are dividing it, we can go in denominator. So it is only for addition, multiplication, and subtraction. This is called as the remainder theorem. So what is the application of it? The important part is the application. The application is if I say, what is 4 raised to the power 8 upon 3? What is the remainder? You know 4 raised to the power 8 means 4 into 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 4. And if I divide it by 3, I need to check what is the remainder. So what we just saw is you need to check individual remainders. This individual remainder is 1. This will also be 1, 1, 1, 1, 1, 1, 1. And there is a sign of product in between them. So 1 into 1 into 1. This is going to be 8 times and hence 1 raised to the power 8 will be the remainder and 1 raised to the power 8 is 1. So answer here is going to be 1. Similarly, if I say 5 raised to the power 18 divided by 4, what is the remainder? So all you need to check now, what is the individual remainder from here? The individual remainder is 1. You have to just raise the power as 18 and it is going to be 1. The answer is going to be 1. That means if the individual remainder is 1 for the base and the divisor, whatever the power will be, the answer is always going to be 1. If I say 6 raised to the power 83 upon 35, what is the remainder? So you can just write this 6 raised to the power 83 as 6 raised to the power 2 into 6 raised to the power 81 separately. Or you can just write 2 raised to the 6 raised to the power 2 into 41. That will take care of 6 raised to the power 83 and 6 raised to the power 1 separately. And 35 is the divisor. Why did we do this? So that we can make 36 out of it. So it will be 6 raised to the power 2's power 41 into 6 raised to the power 1 upon 35. Now this is going to be 36 raised to the power 41 into 6 raised to the power 1 upon 35. You know, the individual remainder here is 1, and 1's power anything is going to give us 1. Here the individual remainder is going to be 6 itself, because 6 is already lesser than 35. So it is going to itself be the remainder, and the sign between being into, so 1 into 6, 6 is going to be the final remainder for this question. So this is how you are going to solve for the questions, and you have to create a number which is 1 more than the denominator. What if you can't? If you can't create a number 1 more than, so you need to check, can I go for the number 1 less than? For example, if I say 3 to the power 4 upon 4, what is the remainder? Now you should know 3 to the power 4 is 81. So 81 by 4, answer is going to be 1. Answer should come out to be 1. So how that will work? See, if I say 3 by 4, what is the remainder? When I say there are 3 sticks, you want to make a group of 4. So you say 3 will be the remainder because all the 3 sticks will left. Or you can say there is 1 stick less as compared to 4's multiple, or 4. So remainder is -1 also, you can say. Because there are 3 sticks extra, you are saying remainder is +3. But there is 1 stick less, so you can say remainder is -1 as well. And -1 raised to the power 4 is going to be +1. And hence the answer is +1. So this also is called as the remainder. That means there is a concept called the negative remainder. Let me take proper example for this. If I say 7 by 5, what is the remainder? So that means there are 7 sticks. If you say, I can make group of 5 sticks, 1 proper group of 5 sticks. So extra, there will be 2 extra sticks. So remainder will be 2. But some might say, had there been 10 sticks, I would have made proper 2 groups of 5 each. But there are 3 less sticks for me. That means the remainder is -3. So there are two remainders for any division. One is called positive remainder, another is called negative remainder. Negative remainder is just the concept we use to solve the questions. It is not the thing, or you can't answer a negative remainder. Negative remainder is concept we solve. That means if you come across a negative remainder, first you should be able to find out the positive remainder. So if I say for this division, the negative remainder is -3. What is a positive remainder? So all you have to do is 5 minus 3. That is 2. 5 means the divisor. Divisor plus negative remainder or -3 is going to give you your positive remainder like this. If I say for a division n upon 8, the negative remainder is -5. What is a positive remainder? So all you have to do is 8 minus 5, that is 3. 3 is going to be the positive. So this is how you find the positive remainder from a negative. So if I say 3 raised to the power 7 upon 4, what is the remainder? So this time, you are going to form the individual remainder from here. 3 by 4, the individual remainder is -1. And -1's power 7 is going to be -1 again. If the power is odd for a negative number, the answer is negative. So answer here is -1. But as I said, minus can't be the answer. It's just the concept. So if you're getting -1, you have to subtract it from 4. And the actual answer is going to be +3. So for this division, the remainder is going to be +3. So I hope you got this. Let's solve some question based on this. what is the remainder for the following division? So you can use different theorems now here, but the easier ones we can use first is the cancellation rule. We can cancel out 2 from both sides. So we are cancelling out 2. So it will be 4 or 2 into 4 raised to the power 784. Because one of the 4 we took out and 2 will be cancelled out of it. And in the denominator, it is going to be 3. This here is -1 and this here is +1. And the sign between is into. So -1 plus 1. -1 plus 1 is going to be -1. The product is -1. And 3 minus 1, that is 2. So positive remainder for this is 2. But we cancelled out 2 as well. If we cancelled out 2, the final answer is going to be 2 into 2. That is 4. And 4 means 1. Because 4 can't be remainder if you are dividing by 3. If your remainder goes beyond the divisor, you have to again divide the remainder and check the final. You have to again divide it by divisor and check the final. But if you now see the pattern method here, if I say 4 raised to the power 1 upon 6, sorry, the answer is going to be 4 itself. In this case, the divisor was 6, which is not less than the 2 into 2. The 2 that we cancelled out is 4. Because the actual divisor is 6, the answer is 4. 4 is less than 6. So 4 can be the remainder. So for this division, remainder is 4. Had it been this division, then the answer would be 2. Okay. Now if we check the pattern here, 4 by 6, the remainder is 4. 4 square upon 6. 4 square is 16. 16 if we divide by 6, 12 goes, the remainder is 4. 4 raised to the power 3 upon 6. 64 by 6. The answer is again going to be 4. So every time if you divide 4's power by 6, the answer is coming 4. That means here also the answer should be 4. So pattern method is also sometimes very, very useful. Let's see one more. What is the remainder for following division? If you check this individual remainder, that is 1. And 1's power 59. It is 1. The answer is going to be 1. Let's see next one. Negative remainder as a concept we saw. Let's check some previous year question from different exams now. Least number to be added to this to get a number which is divisible by 87 is. So first of all, for this exact type of questions, you can just check the options. Besides, what is 87? 87 is 29 into 3. That means what number should be added so that it is divisible by 29 also and 3 also. 29 also and 3 also. So what is the divisibility of 3? 3 means sum of digits. So 3, 5 plus 1 is, this number is already divisible by 3. So whatever you are adding into it should be multiple of 3. In this case, all 4s are multiple of 3. That means by adding what number out of 4 options, your answer becomes multiple of 29. For that, you need to know the table of 29 as well. So if you add the first option, 13,000, or we can just check first, if we divide this number by 29, what is the remainder? If you check here, for this division, it is going to go 29 4 times and 7 times, then 7 times. So 33 means 18 is going to be remainder. Remainder is going to be 18. So that means if you subtract 18 from this number, if you subtract 18 from this number, because 18 is the remainder, if you subtract 18 from this number, it will be divisible. But we are said add. Least number should be add. So that means if you add, because now we want a multiple of 29. So we have to add such a number such that it will stay the multiple of 3 as well and 29 as well. So this number already has 18 extra than the 29's multiple. So if you add 18 to 29 means 11 more. This number 13,862 will be a number which will be divisible by 29, but it won't be now divisible by 3. So we have to add again one more 29 into it. So if you add one more 29 into it, it is not, first we added 11, then we add 29. It's still not, it will not be still multiple of 3. So we'll have to add one more 29. So that 29, 20, 58, 50, 69. So total 69 we'll have to add to this number so that it becomes multiple of 29 as well and 3 as well. But as I said, for these type of questions, options are the better way to solve. Just add every option and check by adding which of the option you are going to get the multiple of 3 also and 29 also. That will be easy way to do it. Let's see one more. What least number must be added to this number so that it is completely divisible by 19? Again, you can just go by options. If you divide this number by 19, the remainder is going to be 2s are 38, 33, 1s are and then 7s are. So it is going to be 30. 2, 3. That means 16 is going to be removed. Had it been 4, 1, 2, 3, it would be totally divided. So extra is 16. That means this number already has. Sorry. I made a mistake. It was 1 here. So 2, 3 goes. That means the remainder is going to be 8. Remainder is going to be 8 in this. So if the remainder is 8, that means this number already has 8 extra. We want a multiple of 19. So 8 already extra. So we'll have to add 11 more so that it becomes multiple of 19. So that means the answer is going to be 11. Easy? Let's see this. What is the remainder when this number is divided by 35? So this again can be manually done rather than using any theorem or theory, Chinese remainder or anything. You can manually also do. Okay, so if you divide it by 35, it is going to go with 192 times, and the remainder is going to be 9. So the answer here is going to be 9. Easy. So if small scale questions are there, you can better do manually, provided your tables are good. Okay, let's see different type of questions. It says in a division sum, the divisor is D times the quotient Q and 5 times the remainder R. If remainder is 46. So if remainder is 46, the divisor D is 10 times the quotient and 5 times the remainder. So divisor D is 5 times the remainder. That is 46 into 5, 230. And it is 10 times the quotient. So quotient is going to be 23 because this is 10 times of quotient. So quotient is going to be 23. The dividend will be. So you know the dividend is divisor into quotient plus remainder. So 23 into 23. +5290 plus 46, that is 53 36. The answer is going to be 5336. Okay, let's see one last question for this topic. Sum of the digits of two-digit number is 1/7 of the number. The unit digit is 4 less than the tens digit. If the number obtained on reversing a digit divided by 7, the remainder will be. So for such question, it is better to analyze first a little. Directly don't go for the making equations without even thinking much, because then it is going to be really tricky if you to take many variables and solve the equation. Let's see, sum of digits of a two-digit number is 1/7 of a number. That means whatever the number we are talking about, if we are doing 1/7 of it, that means the number must be multiple of 7. So we are talking about a two-digit number which is multiple of 7 and whose sum of digit is 1/7 of it. And also unit digit is 4 less than the tens digit. So even if you write down the multiple of 7, which are two-digit number, where unit digit is 4 less than the tens digit, we can form our answer. So 7's multiple are going to be 14, 21. Unit digit should be 4 less than the tens digit. Okay, you just have to maintain this. 28, no. 35, no. 42, no. 49, no. Then next will be 56, no. 63, no. It is only 3 less. We want 4 less. Next will be 70, no. 77, no. 84, yes. In 84, the unit digit is 4 less than the tens place. Also, the sum of digit, which is 12, is 1/7 of 84. Sum of digit is 8 plus 4, 12. So yes, that means 84 is the number. They are saying if the number obtained reversing is digit, that means 48 if divided by 7, what is the remainder they are saying? 48 if divided by 7, the remainder is going to be 6. Easy. So I hope you understood this topic. As I said, in good exams, the question could be the ones that we are seeing under different theorems. But in easy exams, the question also will be easy like this. Thank you for watching this. Bye-bye. Have a good day.